Hello, welcome back. In this segment, I want to summarize all the natural deduction rules that we have learned. So there are two categories. One is so-called basic rules. Basic rules, as the name implies, they cover the foundational rules for logic. Okay, so let's start with the summary of basic rules first. The first one is and. You see here there's an and. You have two premises, say pi, psi. You are able to introduce an and. If you know pi and psi are true, using and introduction, you can conclude pi and psi is true. Okay. Similarly, on the elimination side, if you know pi and psi are true, you can eliminate either pi or psi. That's the reason why we have eliminate. In this case, eliminate the second part, keep the first part. Similarly here, eliminate the first part, keep the second part. Okay, so essentially it's same as eliminating one of the components of an understatement. Moving on to the or. If you know pi is true, you can introduce another statement, psi. Similarly, if you know psi is true, you can introduce another statement, pi, in the front. That's the introduction. For the elimination using or, if you know pi or psi is true, if you assume pi is true and you're able to arrive at some formula. Similarly, psi is true and you're able to arrive at some formula. Those two formulas must be the same. Then you can eliminate the or and say this formula is true because, either you follow this thread of reasoning or this thread of reasoning. And in both threads, you arrive at the same conclusion. Therefore, since you are given pi or psi is true, you can eliminate or. And moving on to the third rule, implies. Suppose you start with pi and you reach chi using the natural deduction rules, then you could say pi implies chi. That's the introduction. Okay. Suppose you know pi is true and pi implies chi, then you can deduct chi. That's the elimination of implies. Moving on to not introduction. Suppose you start with some premise pi and you end up with a contradiction. That means you can introduce a not. That's the not pi. All right. What about elimination? Suppose pi is true and not of pi is also true. That means you have a contradiction. That means it's not elimination. Moving on to the contradiction. In the contradiction case, there is no notion of introducing something. However, there is a notion of eliminating. Suppose you start with contradiction and you are able to derive any pi, which is possible. That's basically contradiction elimination. Okay. Finally, in the basic rule category, double not introduction is not there because we can derive it through the derived rules I have shown during the discussions in other segments. Okay. How about elimination though? If you have double not with a pi, you can arrive at pi. This is called double not elimination. Okay. So there are only 6 basic rules. All other rules can be derived from these 6 basic rules. That's fascinating. There are so many millions and millions of problems you can solve if you know these 6 rules very well. Okay, let's move on to the derived rules. Why do we have only 4 derived rules? You could derive many, many more rules, like many theorems can be derived and so on. But it turned out that these 4 derived rules are so foundational, more or less like basic rules. That is the reason why we enumerate them here. That's the reason why this book, Logic and Computer Science, is treating those 4 rules as useful derived rules. If pi implies chi and not chi, then we can conclude not pi. That's the modus tollens rules that we learned. And again, this is the double not introduction. That's the reason why it's empty here. And proof by contradiction. Suppose you start with not of pi and you end up with the contradiction. That means it's pi as a conclusion. And the law of eliminating middle is pi or not pi. Okay. All right. Thank you very much for your attention.